Alrighty, in this video we are going to be doing more complex area of polar graphs problems where we either have area between two curves or area shared by two curves. If we have area between two curves, we're just going to be doing the same thing that we've been doing back in AB, where we are doing top minus bottom or right minus left. And in this case, we aren't really going to need to change my variables because it's always going to be d theta. So you don't have to worry about dx or dy here. If we have area shared by two curves, then we're going to split the curve up into two regions and see how they are defined. And we'll see that on, let's say, number 7 and number 8. But looking at number 5 here, it's going to be important for us to understand which curve is what. On the AP exam, they'll probably give you the curves, and you're probably going to have to figure out which curve is what. And most likely they will give you the curves. If not, then it should be something easier for you to sketch out, just like the petals that we did back in the previous video. So here, the circle in red is 3 cosine of theta, and then this right here in black is 2 minus cosine of theta. I kind of need to figure out what my intersection is right here, because if I want inside, I want this right here, but then if I want outside, I want this right here. So inside of 3 cosine of theta, but outside of 2 minus cosine of theta is this region right here. Okay. What we are going to do now is go ahead and find my intersection. So I am going to do 3 cosine of theta is equal to 2 minus cosine of theta. That's going to give me 4 cosine of theta is equal to 2. Cosine of theta is equal to 1/2. And we need to figure out when cosine is equal to 1/2. And that is whenever we have pi over 3 and 5 pi over 3. So this tells me that my intersection here is 5 pi over 3. And then my other intersection right here is 5 pi over 3. Or in this case, negative pi over 3. Just like the previous video on number 4 here, whenever we did negative right here, I'm not a fan of that. So what I am going to do here is use symmetry and go from 0 to pi over 3 and then multiply that by 2. So essentially I'm going to find out this area first. So I have 2 times 1/2 of my starting point of 0 and then pi over 3, because that's going to swoop everything here. So I have 0 and then pi over 3. That's going to swoop that. I'm going to do right minus left. So in this case, my right is going to be 3 cosine of theta squared. And then my left is going to be 2 minus cosine theta squared d theta. All right. Now, I am going to be lazy because it is 10:57 right now. That's a pi. What I'm going to do is put this into the calculator. Obviously, if number 5 was a calculator inactive problem, you will need to probably simplify this and then use the reduction identity to simplify cosine square of theta. But that's just a little FYI for you to do on your own after we do the calculator version of this. So what we're going to do is just plug and chug this into the calculator and see what this area is. We are going from 0 to pi over 3. And then we have 3 cosine x square. Let's make sure that the square is actually multiplying by everything. Minus 2 minus cosine of x, and then square, hit enter, and then you see that my area is going to be 5.196. 5.196. And that's going to be the area of this and this right here, so the whole pink region. Of course, now what I want you guys to do is probably do this without the calculator and actually do it so that you have practice on simplifying all of that. All right, number 6 is going to be very similar right here, where we have r is equal to 3 sine of theta, and then the outside being 1 minus sine of theta. So inside, outside means that we have this whole thing right here for number 6. I know, crazy. What I'm going to do here is do top minus bottom, but I'm not going to really do top minus bottom. What I am going to do here is, since this is almost everything for 3 sine of theta right here, I'm just going to go ahead and find this area, including these small little parts right here. So I'm going to include that. So technically this is going to be, let's see, 2 times 1/2, 0 to pi over 2. Once again, I am going to be using symmetry right here, so I'm going from 0 to pi over 2, and then I'm going to multiply by 2 because of the left side. This is going to be 3 sine of theta square d theta. So that gives me the area of everything, including these 2 small parts. Now what I'm going to do here is subtract that from these 2 small parts. Well, in order to do that, I kind of need to find my intersection of this right here so that I can find my lower and upper bounds. So I am going to set this equal to each other. Now, as a disclaimer, I did have a typo, but the typo still works. Obviously, we don't know what sine of 1/4 is. That's why that's my little typo. I think this was supposed to be a plus, but then I kind of graphed it so that it was a minus. But, you know, it is what it is. You're going to get some answer, and it's going to be right. Theta is going to be inverse sine of 1/4. So this one, we actually really do need a calculator for this one. Okay, so that right there is going to be my lower bound. And then, of course, my upper limit is going to be this pi over 2 right here. So I'm going from inverse sine of 1/4. And then I am going from that to pi over 2. Once again, I am doing symmetry right here. So technically what I can do is do that. But then once again, the 2 times 1/2 is just going to be 1. So that's just that. So I'm just left with that. And this is going to be 1 minus sine theta squared d theta. This one, just plug this into the calculator and see what happens for number 6. So I have the integral from 0 to pi over 2 of 3 sine x squared. Okay. And then I have minus my integral from inverse sine of 1/4. I know, embarrassing. And then pi over 2 of 1 minus sine x squared. And that's going to give us 6.906. 6.906. That's the area of this pink region right here. All right, so number 5 was using top minus bottom. Number 6 used essentially a modified version of top minus bottom, where we just took the area of the whole thing of 3 sine of theta and then subtracted from these two parts right here. And then number 7 right here, this is going to be kind of interesting, I would say. So we want to find the area of the region between r is equal to 4 and 4 plus 4 cosine of theta. Okay, so here, if I were to use symmetry, that's going to be this right here. But here's one problem if I am doing symmetry. Notice that my intersection is right here, which means it kind of cuts my symmetry right here into two parts. I need this part right here, and then I need this part right here. So what I'm going to do here is use symmetry, but we're going to have to use two parts. This is going to be the area shared by two curves, essentially. So this first curve, and then this second curve right here. All right, so before we do anything, we got to figure out what my intersections are. And hopefully you know that this is pi over 2 right there. And then this is 3 pi over 2, but we kind of don't really need that just because we're looking at symmetry. So I only really care about this pi over 2. Okay, so I have 1/2 times 2, of course, the integral from 0 to pi over 2. And if I'm doing the 0 from pi over 2, then I'm looking at, let's say, this region right here. And if you look at this region right here, this is going to be my red circle. So this means that my integrand should be 4 square d theta. That's my first part. Now my second part here is going to be this thing in green. All right, so that is going to be, once again, 2 times 1/2, just because I want to reflect it. My integral from pi over 2 to pi. And notice how here, this kind of represents my black curve right here. So that right here is going to give us 4 plus 4 cosine theta square d theta. If I were to simplify this, this is going to become 1. This is going to become 1. So now I just have this right here in pink plus this right here in green. Nope, sorry, this is pink. This is green. So this is green, and then this is pink. And what I'm going to do here, of course, is go ahead and use my handy-dandy calculator and figure out what my answer is here. So I have 0 to pi over 2. Then 4 square is 16 dx. Plus the integral of pi over 2 to pi. This is going to be my black region. So 4 plus 4 cosine of x square. Oops. Oh my Buddha. What did I do wrong? Four plus 4 cosine of x. Okay, let me do that again. Apparently I didn't like that. So 0 to pi over 2 of 16 dx Maybe I should do that. Oh, maybe that's why. Yeah. I'm going to separate this. And then we have pi over 2 to pi. 4 plus 4 cosine of x square. Much better. Then I'm going to add it. That's going to give me my area of 30.831. So 30.831. All right. Likewise, for number 8, we want to find the common interior of r is equal to 4 sine of theta and r is equal to 2. So it's basically the inside. I want this right here. Now, you might think, hey, let's do top minus bottom. Well, plot twist, we can't. And the reason why is because if you actually zoom in a little bit, you're going to see that my intersection right here only covers this upper portion, right? And let me do a different color. This, oops, great. This upper portion right here, and only this right here. So that means I'm going to have the area in pink right here that we initially had. But then I also want some area right here, the small area. Let's say that this is green again. So this small area right here, and this small area right here. Lucky for us, we do have symmetry going on, so this is going to be very helpful in terms of my setup. Before I do anything, I should probably figure out what my intersections are so that I can work this problem out. So I have 4 sine of theta is equal to 2. Sine of theta is equal to 1/2. And that happens whenever theta is equal to pi over 6 and 5 pi over 6. Okay. Now, if I were to look at this part right here in green, this part right here is filled by my red circle, which is going to be 4 sine of theta. So whenever I'm setting up my thing, I'm going to have 2 times 1/2, then 0 to pi over 6, and then that is going to be 4 sine theta square d theta. And that is going to give me this right here. So this and this combined. So that's why I have a 2. And then, using my pink, I'm going to have 2 times 1/2. I'm going to start at pi over 6. And then I'm going to end up at pi over 2 so that I don't overlap my thing. So that I get symmetry right here. So that's going to give me pi over 2. And that right there focuses on r is equal to 2, my black curve right here. So 2 squared is just going to be 4. So I'm going to have 4 d theta. Notice that this right here, the 2 times 1/2, then the 2 times 1/2, that's going to be 1. So that essentially cancels out. And you're left with this lovely thing right here. And then what we're going to do is just go ahead and put this in our handy dandy calculator and see what we get. So we have 0 to pi over 6. And this is from 4 sine theta square. So 4 sine theta square. And then I am going to do pi over 6 to pi over 2 of, let's see, I said 4. That's going to give me that. If I add these two together, that's going to give me my area, which is going to be 4.9134. 4.9134. All right. Number 9 here, you guys can use top minus bottom. We want inside of 1 plus sine theta, and then outside of my circle. So that's going to give me this right here, which is going to be top minus bottom. So nothing to worry about right here. That's because my radial line starts right there and right there. So we're kind of good there. Number 10, we have an inner loop of r is equal to 1 plus 2 cosine of theta. So you want this thing, this thing right here. For this one, you're going to use symmetry. You got to figure out where we were starting, so what this is right here and what this value is right here before you do anything. So this one, probably use a calculator and then trace out what this is and trace out what this is so that you can use symmetry. Or you could just figure out what the whole thing is and not use symmetry. Either way, that works. Likewise, same thing for this one. You guys can go from 0 to pi if you don't want to use symmetry. Okay, 11 says area common to R and R. So the inside region right here. This one we're going to do together because this one's a lot of fun. Because it's very similar to that one problem that we did earlier. So here, if I were to draw my radial lines from my intersections, I am going to get this right here and this right here. Kind of need to figure out what that is, so I'm going to go ahead and solve that out. I am going to add 2 cosine of theta, so that's going to give me negative 4 cosine of theta is equal to 2. Cosine of theta is equal to negative half. And that works whenever we have 2 pi over 3 and 4 pi over 3. So this tells me that this is 2 pi over 3. This tells me that this is 4 pi over 3. Okay. Now, remember that that's going to give us this little swoop right here. But I still want this region right here. Even though it's kind of small, we still need this. And we still need this. All right. So if I'm going to do that, I'm going to go ahead and think about where I am swooping. So here I'm going to start at pi over 2. And then if I sweep my way to the left, I am going to get this right here, which is going to be my red graph, which is going to be negative 6 cosine of theta. So this tells me that if I have 1/2 times 2, once again, because I'm using symmetry right here, I'm going from pi over 2 to 2 pi over 3 of negative 6 cosine theta squared d theta. So that's my first part. My second part is going to go from 2 pi over 3 to pi right here, so that makes symmetry. So I'm going to have 2 times 1/2 of 2 pi over 3 to pi. Now looking at this is going to be my black curve. And this black curve right here is my 2 minus 2 cosine of theta. So I have 2 minus 2 cosine of theta squared d theta. Okay, once you do that, 2 times 1/2 is just going to be 1 because we use symmetry. And what you're going to do is just put this into the calculator. I'm not going to do that for you because I think you could do it on your own and then verify that your answer is correct. That's going to give us 15.707. All right, one more. Let's see, 13. We want the area between 2 sine of theta and sine theta plus cosine of theta. So once again, we have this right here, except we have a little oopsies because we only have this region And then we have this region. Oh no. But first, we got to figure out what my intersection is between this and this. So go ahead and set 2 cosine theta equal to sine theta plus cosine of theta. I'm going to subtract sine of theta, so that's going to give me sine theta is equal to cosine of theta. That is true whenever we have pi over 4 right here. So that's going to give us this right here. All right, so if I were to, of course, in 3 pi over 4. If I were to do my purple region right here, that is going to be my red, and that's going to be 2 sine of theta. So I have, I'm not going to have symmetry, so I'm only going to stick with 1/2. So that's going to be important because we don't have symmetry going on here. So we have 1/2, 0 to pi over 4 of 2 sine of theta d theta. So that is my purple region right there. I have my green region, and you will also see that I do not have symmetry going on with the green region. And that is going to be my black curve right here. That is going to be from pi over 4 to 3 pi over 4 of sine of theta plus cosine of theta square d theta. Now, I trust that you can put this into the calculator and call it a day. You are going to get 1.0707 for this one right here. I know I said 13 was the last one, but I really like 14 too. We have inside of 2 plus cosine 2 theta and outside of 2 plus sine of theta. 2 plus sine of theta is going to be this black region right here. And then this red region right here is 2 plus cosine 2 theta. If we want inside of that, little peanut, and then outside of the black, that's going to give us this right here. And this right here. Well, once again, you'll notice that you have symmetry going on from the left side and the right side. Here, I am going to go from this to whatever this is right here. This is going to be negative pi over 2. And then if you haven't really guessed out what this little thing right here is, this is pi over 6. This is pi over 3. And this is pi over 2, if you haven't noticed that already. So I'm going to give you a hint that this is pi over 6. Meaning that I'm going to do right minus left of this lovely thing right here from negative pi over 2 to pi over 6. I am going to take the lazy route and put this into the calculator. Sometimes the AP exam might say set this up, and I'm just going to do that and then give you the area. But I do want you to probably type this in. We have 2 times 1/2 of the integral from negative pi over 2 to pi over 6. We are going to do right minus left, so we have 2 plus cosine 2 theta minus 2 plus sine of theta. Oh, I forgot the square. Square, and then square d theta. All right. Once you do that and put this into the calculator, you are going to get 5.5209. All right, that being said, this is going to be the last video of new material. The next video is going to be on polar FRQs. So we're just going to be working on some FRQs there.